Why do they say that when an object reaches the speed of light, time stops flowing? If you were sitting in a super cool cosmic spaceship, accelerating like crazy, could you reach the speed of light? If you pushed even harder to try to surpass the speed of light, what would happen next? Starting from middle school to high school, our teacher always told us that the speed of light is an absolute limit, like an invisible, towering wall, impossible to surpass. Most of us have accepted this premise, yet very few have truly questioned it, explored the reasons behind it. After all, this limit has sparked countless mind-bending debates. Is there really an unseen wall blocking our way? There's still this mysterious force at play. Just when we're trying to break through this barrier, it yanks us back hard. The truth behind this is way more complicated than you think. According to relativity, when an object reaches the speed of light, time dilation effects hit their limit. Time no longer passes. It just becomes infinitely slow. When something's moving at the speed of light itself, time stops in its tracks. To figure this out, we gotta wrap our heads around the speed of light first. For us humans, the speed of light is mind-blowingly fast. But in the grand scale of the universe, it's like light is crawling at a snail's pace. Right now, everyone's buzzing with excitement about space exploration. All of us are eager to visit other planets. I even hope we can travel beyond the solar system and head towards the vast Milky Way. But the thing is, the limitations of distance keep us confined to this tiny solar system. In our everyday concept of speed, light moves so fast we can't even feel it. But in the face of the vast universe, the speed of light is simply insignificant. Take the sun, for example. It takes 8 minutes and 20 seconds for sunlight to reach us. In other words, if the sun suddenly went on strike and disappeared, we wouldn't even notice for 8 minutes and 20 seconds. And it takes over 4 hours for light to reach Neptune, for 0.5 billion kilometers. And that's just within our solar system. When we look at other stars in the Milky Way, the situation becomes even more serious. The problems from those stars in the galaxy, reaching us with light, it could take tens, hundreds, or even thousands of years. So when we gaze up at the stars and watch the countless stars in the Milky Way, we're actually seeing scenes from their past. And as we gaze into the depths of the universe, we can see even further into the distant past, because we can't surpass the speed of light. So if we want to reach the end of the Milky Way, it would take millions of years. If we want to go to other galaxies, that's even more out of reach. It's going to take a long, almost unimaginable amount of time. This speed limit, man, it's like an invisible rope, keeping us firmly stuck on Earth. So, unlocking the mystery of light speed might just help us understand the universe better. Maybe even open the door to interstellar travel. But we gotta figure out why light speed is so special. We gotta go back in time first. Check this out. How scientists discovered the secret of light speed. The story begins with the Paris Observatory in 1676. There was a 32-year-old Danish astronomer. His name was Oliver Moore. He was like a patient stargazer, scanning the night sky night after night. So what was he up to? Turns out, he was observing Jupiter's fastest moon, Io. That was his job at the time, calculating the Japanese time of Io to help sailors in the vast ocean find their way. But in this seemingly mechanical repetition of observations, he discovered a mysterious phenomenon. As Earth gradually moves away from Jupiter in its orbit, the Japanese time of Io would be late. And when Earth approaches Jupiter, the sun will rise a little earlier than expected. These differences are very subtle, but they have always been consistently present. At that time, most astronomers blamed it on the instability of the orbit of Io. But Romer didn't think so. He had a very bold intuition. Could it be that light travels in space at a certain speed? Just imagine, before that moment, everyone thought that everything in the universe happened in an instant. The sky is like a grand theater without any delay. And Romer's idea was like a lightning bolt that shattered people's understanding of the universe. He realized that when Earth is farther from Jupiter, light has to travel a longer distance, so delays occur. With the limited tools available at the time, and the estimate of Earth's orbit, Schroeder's estimation, the speed of light is approximately 200,000 kilometers per second. This was a huge leap at the time. For the first time, humans discovered light doesn't arrive instantaneously. It has its own speed. It has its own rhythm. Fast forward 2 centuries to the year 1849. A 29-year-old French physicist, Siberian skyline, decided to do it here on Earth. Take on the challenge of measuring the speed of light. His idea was simple yet brilliant. Between 2 cities, built an incredibly cool device. This device has a light source, a gear that can spin at high speed, and a big mirror 8 kilometers away. The principle is actually pretty simple. The light starts from the light source, through the gaps in the gears. The camera lens is reflected by the mirror and then returns. If the gears rotate fast enough, in the time it takes for the light to travel back and forth these 16 kilometers, a moving ruler can just block the light. By carefully adjusting the speed of the gears, the bandits' hideout found the exact point where the light just disappears. And then we can calculate just the time it takes to complete this journey. He came up with a figure of 31.5 million kilometers per second. And it's pretty darn close to modern values. You know, that's a remarkable number. It's proof that light isn't just some abstract concept. It's something that can actually be measured, a physical phenomenon that can be observed to truly exist. But in the years that followed, another experiment dropped a major bombshell on the world of physics. We're heading back to Cleveland in 1887. We got physicists Albert Michelson and Edward Maury. They're gearing up for a groundbreaking experiment. People back then thought light behaved just like other waves. They believed it needed a medium to travel through. So they cooked up this idea of an invisible, a sort of unseeable, everywhere-at-once material. They called it the ether. Light was thought to travel through this mysterious... That's where our story really begins. The whole space is filled with this mysterious substance. Going by logic, if the Earth is moving at a speed of 30 kilometers per second, moving around the sun in ether time, then the speed of light transmission should vary based on the direction of Earth's movement. It's like swimming in a river. Swimming with the current is faster. Against the current is slower. Swim perpendicular to the direction of the water flow. The trajectory will also be distorted. Michelson designed an extremely accurate dry fire instrument. He split the light into 2 beams, emitting along 2 perpendicular directions, and then recombine them. If the ether really exists, and light travels in different directions, requiring different amounts of time to propagate. So, when we interfere with it, we'll see visible interference, the gaps between the stripes. The calculation is pretty straightforward. The expected results are very clear. We should be able to measure a displacement of 0.4 stripes. But when they started the experiment, they found nothing at all. No displacement. No changes. They rotated the device 90 degrees, still coming up empty. Repeating the experiment at different times in different seasons. Still no change. The speed of light is the same in all directions. This result is just so perplexing. It's like swimming in a raging river, only to find that no matter which way you swim, the speed remains exactly the same. How is that even possible? just when everyone was freaking out about the speed of light issue and losing their minds. In a regular patent office in Boston, there was this 26-year-old guy with a messy head of hair, rocking a mysterious smile on his face, just doodling in a notebook. No one would have guessed that he would go on to become a world-famous, shaking up the whole scientific community. Albert Einstein. Einstein came up with an earth-shattering idea. If it's not light that adjusts to our movement, but time and space themselves bending towards the eternal light. That's the idea that led him towards modern physics. One of the most important discoveries. He started pondering how to ensure all across the railroad network it shows the same time. How do you define events happening far away? These questions made his thoughts go deeper and deeper. Einstein asked himself a simple, yet incredibly disruptive question. If I were to run alongside a beam of light, what would happen? According to classical physics, I should see light behaving like still waves, frozen in outer space. But Maxwell's electromagnetic Hall equations show stationary electromagnetic waves simply defy physics. This is a fundamental contradiction. Einstein boldly made a choice that changed history. He didn't alter the Maxwell equations. Instead, he challenged our traditional understanding of space and time. He proposed two revolutionary assumptions. The first assumption is laws of physics are the same in all inertial reference frames. In other words, there's no special reference frame in the universe. You can't claim to be absolutely still. The second assumption is even more unbelievable. The speed of light in a vacuum is constant for all observers. It never changes. This assumption sounds absolutely crazy. Light, how is it possible for everyone to have the same speed? This is totally opposite to what we observe in daily life. Just imagine, you're sitting comfortably in a chair on a train going 100 kilometers per hour. You throw a ball forward in the train's aisle. The ball's speed relative to the train is 50 kilometers per hour. So, for the observer standing still on the platform, the speed of this ball is the speed of the train, plus the ball's speed relative to the train. That's 150 kilometers per hour. It's just a simple addition of speeds, aligning with our intuition. But now you turn on the flashlight. The light from the flashlight at every second. We're shooting forward at a speed of 300,000 kilometers. What's strange is, for the observer standing on the platform, the speed of light is still 300,000 kilometers per second. Not more, not less. It hasn't increased at all due to the train's speed. How is that possible? It turns out, it's the magical trickster of space-time playing tricks behind the scenes. To ensure the constant speed of light, time slows down. Space contracts. So the universe is like a clever designer, adjusting its own rules to maintain the stubbornness of light. We always thought time and space were absolute, fixed and unchanging, but in reality, they are flexible and ever-changing, interconnected. That's Einstein, bringing us a revolution in our understanding of time and space. That static cosmic stage in Newton's eyes, here with Einstein, has turned into a vibrant dancer. Time and space will fold, stretch, or snap back with the movement of objects. Stretch or snap back. Everything is changing according to the rhythm of motion. But here comes the question. Why does light have such a special speed? Why? Why is it specifically 30,000 kilometers per second? Actually, it's not something deliberately set by anyone. It's a fundamental property of space-time geometry, deeply ingrained in the essence of reality. This speed determines the causal structure of a universe. It shows us how causes lead to effects, how information spreads, how the universe maintains coherence and logic. If there were no restrictions, cause and effect would go haywire. Results might come before reasons. The universe would become a chaotic mess. Places we can't comprehend. Past, present, and future all mixed up. A tangled mess. This speed limit isn't just some random universe rule. It's the key to keeping the universe coherent and orderly. It's like reality syncing with my inner self. For instance, if the sun suddenly disappeared, we wouldn't notice right away. It would actually take us 8 minutes and 20 seconds to find out. It's not because light takes time to travel. It's because the information of this event itself can't be transmitted faster than this. There's no way to convey it at a faster pace. During these 8 minutes and 20 seconds, the Earth will keep on spinning. The long-gone sun is spinning because of the sun's gravity. The information hasn't reached us yet. That's the speed at which the universe refreshes its coherence. But in reality, we've been racing at the speed of light all along. You might find this surprising. Because from the moment you were born, you've been traveling through space-time at this speed, never stopping for a moment. If this speed defines the transmission of information in the universe and the British relations, then what does this mean for our own existence? What does it imply? Because fundamentally, we are also information, a series of events happening in the universe. We are also part of this grand symphony of life. To grasp this, we need to change our view of space and time. Stop thinking of space and time as separate, and don't just think of space having 3 dimensions. Time is just a steady stream flowing line. In reality, space and time are actually one whole. They make up a concept called space-time, including 3 spatial dimensions and 1 time dimension. Imagine this. Take another look at a map. Here on this map, you can choose to go north or south, or you can choose to go east or west. Even though the directions are different, you are still moving on the same map. The same goes for time and space. You can move more in space, or you can move more in time. But you're always traveling in the same time and space. The most important thing is, in space-time, everything is constantly moving at the speed of light. This total speed is fixed. You can't slow it down, nor can you speed it up. At every moment, you're moving through space-time at the speed of light. The only thing you can do is redistribute this speed between space and time. So no matter how you choose, the overall speed remains constant. It's just distributed differently. The same goes for space-time. Your total speed budget is the same as the speed of light. You can allocate it into spatial movement and temporal movement. When you're sitting still without moving, you're spending your entire speed budget on the time dimension. In other words, you're moving forward at the speed of light in time. When you stand up and start walking, you take a small portion out of your time budget and allocate it to moving through space. At that moment, your speed in time slows down just a little bit, while your speed in space increases. If you were to get in a car and drive at a speed of 130 kilometers per hour, we'll allocate more budget to space. Your speed in time will slow down a bit. If you ride a spaceship approaching the speed of light, then you've almost allocated all the budget to space. For an external observer, your time will significantly slow down. This is what Einstein discovered, time dilation phenomenon. This is not some kind of mysterious effect. It's just speed being redistributed between space and time. So, even if you think you're completely still, in reality, ever since you were born, you've been traveling through space-time at the speed of light. You are a genuine traveler of the universe, an explorer of space-time. From birth to death, you never stopped moving. Every second, you're in the dimension of time, moving forward at almost the speed of light. While photons, on the contrary, they spend all their speed budget on the spatial dimension, always moving at a speed of 300,000 kilometers per second, crossing through space. But for them, time is frozen. Time won't fade away. Photons emitted from a distant star, even after traveling billions of years. When it reaches your eyes, it hasn't aged a bit. Your total speed in space and time is the same as this photon. The only difference is how speed is distributed in space and time. Now it all makes sense, doesn't it? Why being completely still is impossible. It's not just a matter of technology or physical limitations. In essence, it's simply impossible. Not moving means not existing in time, like being frozen in eternity in an instant. Disconnected from reality, essentially ceasing to exist, because absolute stillness is equivalent to non-existence itself. Only by constantly moving through time and space can reality exist, continue, and evolve. So, you are destined to move at the speed of light in time and space, like being invited by the universe to dance an endless dance until the end of time. Next time when you gaze at the stars, don't forget that you're not observing from a fixed point in the universe. You're checking them out. Instead, you're chilling in your own spaceship, flying through time and space at the speed of light, zooming. You can't stop. You can't go back. The universe is carrying you forward in time and space. But in this seemingly bound destiny, there's actually our only freedom hidden within. That is choosing the direction of movement. We can choose to prioritize time, taking big strides in the dimension of time. Or we can choose to travel farther in space and correspondingly slow down in time. We are destined to be travelers in constant motion, but we are free to choose our own path. The speed of light is not a barrier that separates us from other stars. It is actually a part of our very existence. This is a crucial step towards our future. Do you understand now?